think we're going to get started. If some more people trickle in, that's great. So we're going to talk about responsive images today. By the end of this talk, you're going to see how we can make responsive images work really well in Drupal, particularly by using the picture module. However, responsive images are complex, and we have to cover a few things before we get there. Understanding responsive images will make Drupal the easy part. I'm Mark. I work for the city of Minnetonka. I do web and graphic design there. I've been working with Drupal for the last 4 to 5 years. We moved our intranet to Drupal a few years ago, and I'm working on moving our external website to Drupal as well. And we're doing a responsive redesign, and part of that is getting images to work well. So I've been testing out some of the modules with Drupal that help to make that work a lot better, and that's what I'll be talking about here today. So mobile is growing really fast, as I'm sure we all know. I just checked our stats on the website that I manage just a couple days ago, and we're up to 34% of our site traffic is from mobile devices. Last month, our website had 27% of its traffic from mobile devices. We launched responsive emails this last month, and we got a big bump. So I think once we get our main website responsive, we're going to see even more people who are accessing our site from mobile devices. So it's really important for it to work well for those folks. And the problem is that our sites keep getting bigger. We're using more and more complex JavaScript and CSS frameworks, but that's kind of the small part of the problem. 72% of average sites' weight is from images. That's a lot of things to download. And so the more that we can do to slim that down, the better off our users are going to be. We've got responsive websites that shift their layout from working on large displays to working on small displays, but a lot of times when you look at how the downloads are changing, they're not changing very much. You're downloading almost all the same stuff for a mobile site as you are for on a large desktop. And that's not okay. So that's what we're going to talk about. So the first step to making things better is getting our images to work well on every sort of screen imaginable. And we want to get them to appear the correct size, no matter what device they appear on. And for that, we'll turn to responsive web design. I remember reading Ethan Marcot's first article on responsive web design in a list apart a few years ago, thinking this is going to change everything. And it really has. And then a few years ago, saw Ethan in person at an event apart talking about how responsive architecture inspired his vision for responsive design. And it was a really Zen-like experience and great. And since then, we've all been trying to figure this out. Started with some simple principles for responsive design, but there's a lot of complications that go along with that. So let's briefly talk about the basics of responsive design, and it's 3 parts. We have fluid grids, media queries, and flexible images. These are the tools that will help make our images work great, so understanding the basics is really essential. In the last few years, responsive web design has proven to be one of the best solutions for dealing with the multitude of devices that can browse the web. Dozens, if not hundreds of phones are released each year, and each works a bit differently. They have different screen sizes, different resolutions, different browser capabilities, and the variety doesn't stop with just phones. We have tablets, ultrabooks, laptops, desktops, TVs, video game consoles, and Samsung seems insistent that we use ridiculous words like phablet. Tablavisions can't be far behind. The number of different ways that your website can be viewed grows ever more each day. Responsive design is popular because it offers a sensible solution to this variety. Rather than try to understand every single screen that your website might be viewed on, you can design for flexibility. Instead of designs that depend on a certain browser width, your design can be fluid. And really, the web is by nature fluid. We have tried to constrain that fluidity by setting pixel-based widths on our layouts back when everybody had screens that were the same size. Now we're going back to the way that the web was meant to be, fluid, ready to adapt. But don't forget that fluid design had its challenges. In fluid design, your design could get stretched out on a large browser or scrunched up on a small browser, right? Super long line lengths that go on and on and on are as difficult to read as one so short that you only get one word per line. What responsive design offers is a solution to the challenges of fluid design. The addition of media queries to the mix allows us to shift our fluid design's layout at places where our site no longer looks as good as it could. So we start by having a fluid layout, ideally one based on a grid system. Alignment and hierarchy are two powerful elements of design. Grid systems let us create those alignments much more easily. Frameworks like the 960 grid system allowed us to more easily line up our content without manually calculating all the details ourselves. Today we need more robust grid frameworks because we have to have more than one grid system. A 16-column grid for a large screen does not make any sense on a small screen. We need multiple grid systems to handle the different screen sizes that are out there. Tools like Zen Grids or SAS with Compass can help you create your grid without making all the calculations yourself. The way we shift between those grids is with media queries. We define breakpoints, places that we will be shifting our design. Media queries can be based on a lot of different factors, but what we're going to care most about are viewport size and screen resolution. When responsive design started out, some people based breakpoints based on common device sizes, like iPhone resolutions or iPads or common laptop sizes. Now we know that that doesn't work so well because there are so many devices out there with slightly different screen sizes. If you take a look at a table of all the Android devices out there and the screen sizes for each of them, it's nuts. You don't want to have to try to figure out every single one of those. So instead, we start our CSS with a mobile layout, often with one column. That way, if a mobile browser doesn't understand media queries, it still gets basic styles. Lack of media queries is our first media query. We build up our styles for additional devices using min-width. We change our browser size until we find a point where the design no longer works well. The line length is too long, or the hierarchy looks out of proportion, or we have more room for a sidebar, so we move the sidebar up. And at that point, we record the width of the browser, come up with a new set of styles, and then we're ready to go to find the next breakpoint. If we want to make our design as future-friendly as possible, we set our breakpoints based on ems, not on pixels. In most situations, the standard font size is 16 pixels. And 16 pixels equals 1 em. So we do a little bit of math, and you take what would have been the pixel size, divide it by 16 pixels, and then you have your ems. However, sometimes the font size is increased by a user for accessibility reasons. But if we use our ems in breakpoints, then this site design will still work even when the font size gets larger. The layout flexes so that the line length doesn't get too short, and our site is easier to read. Some devices like the Kindle also use non-standard font sizes. So em-based breakpoints help us be flexible for those devices as well. So now we have content-based media query breakpoints based on ems that are future-friendly and will work even as new devices come online that might have different base font sizes. For type and for sidebars and for navigation, this all works fine. The biggest challenge is how we deal with responsive design is our media. The problem is that media tends to have fixed fluid widths in a fluid world. Images, videos, logos. Design depends upon relationships, the establishment of hierarchy. So if we keep our images and videos fixed as their containers change around them, then we disrupt that hierarchy. An image might look really powerful at one screen size, but if the rest of the layout stretches out and now the image is small, the image is not going to have the same sort of power. So ideally, we want our images to change in size as our layout changes in size. And if we get that, then we have our three elements of responsive design: fluid grids, content-based media queries, and flexible images. So making that happen for images is actually really easy. You want images to fill the full width available to them no matter the layout. Then you just add this little line and you're done. So image width 100%, your image is going to stretch to whatever size container it's within. The problem with this is that it'll not only shrink images down, but it can also expand images beyond their original size. If you played around at all with Photoshop, you know that this typically doesn't work out well. Scaling images down means you're taking existing pixels and then finding new pixels that will represent those pixels in a smaller space. That's not always perfect either. Scaling logos or icons down in particular gets problematic. But scaling images up means that you're creating new pixels that didn't exist before. And you don't have the information on how to create those details, so you get blurry photos. 100%. So it'll stretch down all you want, but it won't get bigger and it won't upscale. That's a good thing. If an image has its height defined in HTML, if on the image element it has the height and width on there, then the width will stretch, but not the height. So you have to add this line, height auto, and now that's fixed too. You've got an image that's going to keep the right aspect ratio as you resize it. Older versions of IE, you might hear that phrase a few times, can't handle max width. So we'll put width 100% first, and then they will still stretch down. They'll scale up too, but sorry, old IE, you're just going to have to deal with that. You're dying off, and newer versions of IE are just fine. But newer browsers are going to ignore the width 100%. They're going to take max width 100% as their guideline. So they'll downscale, but they won't upscale. And that's great. So we're all set. That's how we create a responsive image. What if you want the image to not fill the entire space it's within, but just half the space? If you do that, you want to wrap the image in another element. Figure is a good option. It's built to wrap around images anyhow. And so then you set width 50% on figure, and then you've still got max width 100% on the image. Figure goes to 50%, image fills that space, and you're all set. And it still can't extend beyond its original size for the image. So that's good. You want to keep in mind that when you're doing that, when you're setting, that you still want to use the grid. If you're using a grid system, you want your images to match up with your grid widths. It's going to make it a lot easier later on if you know that in this situation an image takes up 1 column or 2 columns or 3 columns of your grid. But what about videos or content in iframes or other embedded objects? How do we scale those? YouTube is a common example for this. There's just a little tweak and we can handle those as well. We set the HTML tags for those in our CSS to be max width 100%, and then the width of those will scale as well. Then again, we've got to deal with the stupid aspect ratio problem. Again, small change necessary to do that. If we know that a video has a 4:3 ratio, which is pretty common, we can set the height to 0. We apply a class to the video element or the iframe element is probably a good way to go. And then we create padding bottom that has just enough room for the video to squeeze in. So we know it's 4:3, so we divide 3, which is the height, by 4, which is the width, and that's 75%. We put padding bottom 75%. Now the image is going to fit in there just fine, and it's going to resize at the right aspect ratio. So that's great. If we have something with a 16:9 ratio, then we need the following. We divide 9 divided by 16, 56.25%. Good to go. That'll stay within the right aspect ratio as well. And there you go. When you apply those classes to your video objects, they will now show up at the right size. We're all set. So there we go. We've now worked out how to show images and other media at the correct size, no matter the device. Short presentation. Welcome to go on to another session. Have images all figured out here. Mm-hmm.
But then you're using those images as something else elsewhere.
Yeah, we'll get to that. We're not actually done here, so I've got lots more to cover here. So I'll answer lots. We'll answer more questions at the end, but we got a lot to cover, actually. So, but just a second of your time. This will only take a second. I left one thing out. Stay in your seats. It'll just take a second to get sorted. So Retina graphics. My iPhone right here has a higher resolution than my laptop. Apple calls this a Retina display. All Retina means is that it has twice the resolution as non-Retina iPhones, which that's a few years ago now. But so that's twice as many pixels wide and twice as many pixels tall. So that's really 4 times as many pixels total. iPhone wasn't the first to have high resolution screens, and not all high resolution screens have 2x resolutions. Some have 1.5x, some have up to 3x, and those are different challenges. So if I'm using flexible images and they're displaying at full width on my iPhone, they'd be 320 pixels wide on an old iPhone display. For a Retina display, the pixels are packed twice as tightly, so I need an image that's 640 pixels wide to fit into the 320 pixel wide space. Now, if I don't use an image of sufficient resolution, then the browser will upscale the lower res image. Upscaling, as I mentioned before, means that the image is blurry rather than crisp. So no problem. Downscaling is easier than upscaling, right? So we'll just use high-res images everywhere. We'll figure out the largest possible size of the image at high resolution, and bam, we're set. Pretty images everywhere. All right, now we're done. Our images look great. Finito, right? Well, hold up. Okay, I left one thing out, so stay in your seats. We're just going to take care of this real quick here. So a slight problem, I forgot that some screens are huge. So if anybody has a 27-inch iMac, that's a freaking huge screen, right? If your site is a single column design with full width images, do you have any idea how freaking big that image size is? With a full, all right, technically Retina screens don't exist for an iMac, but if they did, and it was 27 inches wide, it would be 3,888 pixels by 2,592 pixels. And that is a lot of pixels. If you have the Taj Mahal of bandwidth on your desktop, that's still going to take a while to download. If you're using a phone on the Edge network, then may whatever higher power that you worship have mercy on you, because that's just going to take forever, and you're just going to give up. You only needed an image that was 640 pixels wide for a vertical iPhone screen that's Retina. You just downloaded an image that's 36 times bigger than you needed. And if you're using a non-Retina screen, then it's 144 times bigger than necessary. And that's wasteful and slow and ridiculous. And I'm really proud of myself that I found a picture of something wasteful, slow, and ridiculous. That's a great turtle picture. You could say, hey, who cares about Retina? They're only fancy iPhones, right? But you'd be wrong. There's actually plenty of high-resolution Android and Windows phones too. And it's actually 97% of all phones in use have at least 1.5x resolution. So that's like a lot. That's not something you can really ignore. So, all right, you might be saying at this point, big deal, we'll just serve small, low-res images, and if fancy folk on fancy iPhones have a blurry picture, then who cares? So, I just want to take a small moment to think about images. Why do we have images on our sites? Sometimes we want people to be able to visualize something. They want to see a picture of what they're buying, or where they're going, or what they'll be eating. I want to get that. But really what images help us to do is create emotion. That's me and my daughter, right? Like, that has an emotional impact for me. And we web folk are communicators, first and foremost. Some of us are developers, some are designers, some information architects. But what we're engineering with all of our work is emotion, right? We're helping somebody coming to our site to do something. And to do so, they need to feel happy or hungry, jealous, angry, excited. Images speak to the heart more than the head. They are our best tool for creating emotion. That's a happy frog. That makes me happy, right? Blurry images do not create emotion. And yes, there are ways to make images not show up at all on smaller screens. In some situations, that might work, but if the images are really unnecessary, why are you including them in the first place? If they don't matter on mobile, why do they matter anywhere? So giving up, setting for blurs on a page or no images at all, that's not enough in my book. So here's the heart of our challenge, our real challenge. We want to create images that look great, but we want to be responsible. We want to deliver just enough image to create that emotional effect, and no more. The closer we get to being on target, the quicker our images will load. The closer we get to being on target, the less bandwidth our images will use. And that means that's more websites that our users can go each month when they have their bandwidth capped. And we will have happy, engaged users if we figure out how to make responsive images responsible. See, that stingray is happy. That's a happy stingray. We want our users to be happy stingrays. If we're going to work out how to download just enough image and no more, we first need to understand a bit about how browsers download images in the first place. I am not a browser developer, so I'm doing my best to understand how this works and how it impacts responsive image solutions. So first up, you go to a web page. What's a browser to do? A browser has a few things on its to-do list. I'm pretty sure that's on most days what browsers are planning to do. It has to download things you ask it to download. That primarily includes external JavaScript and CSS files, as well as image files. It also has to figure out what your scripts and style sheets mean, as well as your HTML. HTML is a series of elements that create a document object model, or DOM, when your browser parses the HTML. See, parsely, right? Okay, I'll move on. Your scripts might have an impact on the DOM. Your CSS might change how the DOM is displayed. So the browser has a really high priority to figure out what the heck you're doing with all of your JavaScript and CSS so that it can start painting the browser screen with your site. In fact, the browser is so focused on JS and CSS in the head section of your HTML that when starting, it really can't be bothered with downloading all of your images. But what it can do is start figuring out what it can download once it gets a chance to take a breath. So the browser sends a process to look ahead through all of your lovely HTML to see what you're asking it to do when it gets the chance. It comes up a list of all the images that you're going to ask to download, as well as other JS and CSS files that it isn't already working on. And when it gets a chance, the browser will be on it. This process is called a look-ahead preloader, and it's responsible for 99% of the headaches with responsive images. So here's the deal. The look-ahead preloader is super fast, faster than a speeding bullet, able to leap tall blocks of code. It's a bird, it's a plane, it's super efficient. And I really wish I could make like a P with that style. That would be cool, because that'd be the preloader. The preloader, on average, helps pages to load 20% faster. It might not seem a lot, but when you're on your phone waiting for the image to download, 20% is a big deal. And the problem is that the preloader really doesn't care about the size of the file that it's downloading. It cares about the need for speed, the perception of speed, not whether it's downloading images that are too big. And when you think about it from the browser's point of view, why should it? There are not that many people in the world who choose which browser to use based on bar graphs, but those who do, what do they look at? Have you ever seen a bar graph that says our browser used less bandwidth than the other browsers? Or images on our browser look better than any other? I've never seen that in an Apple Keynote or anything. No, quality and download size aren't in those graphics. Speed is. And forget bar graphs. People care how speedy their browser feels. I end up using Chrome in most situations because it often just feels faster. So browser makers care about speed because you and I care about speed. All right, next thing. So another thing to understand about browsers that impacts speed is radios, cell phone radios. If you're on a mobile device going on to 4G, then your phone actually takes a little bit to get its cell phone radio humming. And once it does, it maintains a connection with the tower for, I've read, about 8 seconds. And after that, it has to start again. So the browser is going to have the best results if it can gather up as many images as possible to download as fast as possible while your radio is connected. If your browser has to wait to process a lot of scripts and style sheets before it starts downloading images, then it might miss that radio window. So it really has to get going. So if you find a solution for responsive images that mean images don't get loaded until later on, then you might cause the cell radio to get humming again. And the more times you ask the radio to do that, the faster you drain the cell phone battery and the slower the page loads. The other thing that slows down page loading is hitting the server with a request. Every time you ask the server to download a new resource, you're using up a thread, a connection between the server and the user, and only so many threads are available at any given time. So every request causes a bit of latency as the server works out how to give you what you want. And the more requests there are, the more latency. So that's why it's a best practice to concatenate, fun word, your JS and CSS files so that you have as few requests to the server as possible. Instead of a lot of separate CSS files, pulling them all together into one file will speed things up. So if you're not already going into Drupal into the Performance tab and turning on the, pulling all the files together, you should do that because that's a good boost for performance. And for images, that's why sprites were a long favored technique. Rather than hitting the server multiple times for a bunch of images, you put a bunch of small images together into one big image, and now you're hitting the server just once. So that's a quick summary of the challenges we face. So anybody Game of Thrones fans here? All right, cool people there, right there. Think of these as the three dragons, the sigil of the Targaryens standing in our path ready to scorch us. I'll move this on because there's only 2 people. So browser challenges, summary, our 3 big challenges, again, are the look-ahead preloader, radio load time, and latency from server hits. So maybe this will work better. If you like Greek mythology, we're talking Cerberus blocking our path into the garden of delight that is responsive images. Wait, that was Hades? Yes, as we look at solutions and the challenges we face, it gets kind of hellish. So now we're going to talk about solutions with problems, the things that we tried that maybe didn't work out as well as we would have liked. So let's take a moment to acknowledge our fallen warriors. Littered upon our path are those who face the beast. It's not that these potential solutions for responsive images don't have some merit and weren't valiant efforts. However, they have chinks in their armor that we must recognize if we are to find a better solution. All right, so we all love JavaScript and jQuery, right? If what we need is the right image at the right size and the right resolution, then let's just use JavaScript to select the right image. We'll start by putting the smallest image size into the image tag so that we can progressively enhance the image for larger devices. And then we need to know the available browser window, the size of the viewport that the image will appear in. We'll grab that with JavaScript. And we're all set. Now we switch our image source with a larger version of the image, which will be too late. The browser has already finished downloading the small image, and now instead of downloading one image that's the right size, we've downloaded one small image and one larger image. So just remember, browsers are fast. The look-ahead preloader gathers up the images and downloads them before our JavaScript can switch out the image source. So now we have more latency because we hit the server twice. And that might not be a big deal if you have just one image in place. But what if you have 5 or 10 or a whole image gallery? That's a lot of extra images. Nearly all responsive image solutions try switching the image source, but the preloader thwarts them. Okay, well, what better way to defeat a monster than if we give it cookies, right? Okay, what if we detected the viewport size and then stored that in a cookie? And now the next time that somebody comes to the page, we already know the viewport size because it's in the cookie, and really quick we can switch out the source element, and oops, the browser beat us to the punch. 2 downloads again. Beating browsers is really tough because they're quick. They're tricky like the jackalope. And this opens up another problem. What if somebody comes to the page on their phone in a portrait location the first time, but then the next time they come, then it's in landscape mode? Well, now the cookie has the viewport size wrong. So that's a problem. Even bigger challenge are CDNs. High traffic sites use content delivery networks to cache files across the globe to speed downloads of site resources by shortening the distance between the server and the client. So all the effort that we put into detecting the right viewport size doesn't do so much good with some of the methods out there if the size appropriate for one viewport is cached by the CDN, and now somebody else with a much larger viewport gets the same cache file. Okay, if the look-ahead preloader is so much trouble, then let's just stop it. Let's just stop it in its tracks. We'll wrap the image element in a no-script element, and now the browser can't see the image, so it can't pre-fetch the image, and we have all the time in the world to download the correct image. This does give us the correct size for the image with only one download, so kind of useful, but we also want images to load quickly and for the whole page as a whole to load fast. No script eliminates the very real benefit of prefetching images to speed up the overall time of the page download. There's also a limitation that larger images will only download then if a user has JavaScript enabled. Most users do, but not all. Depending on who uses your site, could be 1% of your users, could be 2%, 5% in a bad situation. They'll only ever see the small version of your image in the no-script element. So another take on the no-script solution are solutions that load images on demand. Sometimes the images are hidden with no script, and sometimes the URL is hidden in a data URI attribute on a div or a span, and then the image is inserted with JavaScript. So what this means is you're scrolling down, and basically the code waits to download an image until just before you've scrolled to it, and then it loads it. The problem with this, from what we know about browsers, is it speeds up the perceived page load time, but there's a cost because of the radio ramp-up time that we talked about earlier. So loading images on demand sounds great, but if it causes the cell radio to ramp up multiple times as you're reading an article, it's going to hurt your battery, and that means sad face. One last take on the idea of waiting to download images is that we should have element queries. This is something that gets talked about. Rather than deciding which image to use based on the size of the entire browser viewport, we could do so based on just the size of the element that the image is contained within, the figure that we were talking about earlier. And it sounds great in theory because it's a challenge. We'll talk about this later. It's a challenge to plan out what sized images you need to load based on the size of the viewport. So sounds good. However, for element queries to work, we'd really need to wait for the browser to complete the parsing of all the JavaScript and CSS so we could really understand the size of each layout element before starting to download images. And that, again, eliminates the benefits of the look-ahead preloader. It's easier on our end, but it may well slow down page loading for the user. So the common element of all of these potential solutions is a conflict between trying to load the page quickly versus trying to make sure not to download images and other resources that are larger than necessary. We end up loading multiple copies of images, increasing latency from server hits, burning the battery, holding up the browser from downloading the image, and sometimes we still end up with larger downloads than necessary. So we need better options. So now it gets happier. That's the saddest part of the talk. So it gets better from here. So now's the point in the story where we face despair. It looks pretty grim. Cerberus keeps chewing up our ideas and spitting them out. And we need better weapons. We need better tools in our toolbox. So let's take a step back for a second. Remember, our goals are to have images that look great, that load quickly, and that have as little extra file size as possible, no matter what device we're using. That's the game we're playing. And sometimes there are games where the only winning move is not to play. The most responsive image in the world is no images at all. So in other words, anytime you can create visual effects without using images, do that. CSS3 is widely adopted at this point. There's absolutely no reason to use an image file for a gradient, a rounded corner, or a drop shadow. CSS3 handles that natively, and hopefully none of us are doing that anymore. There are some older browsers that won't see your rounded corners. Yes. Does that diminish the emotion that you're trying to create with those rounded corners? Maybe it does. But can you live without it? You can use polyfills like Pi, that's the name of a polyfill out there, to get newer CSS3 effects to show up in older browsers. But doing so potentially adds yet another JavaScript download, definitely adds more scripting to parse, and quite frankly, the results aren't always pretty. There's a lot of bugs that pop up. So that's useful for IE8, which still has a decent market share, but it is diminishing. And sometimes it's okay if your site doesn't look the same in older versions of Internet Explorer. You've got to let it go at some point, and your users are probably going to thank you for it. On that note, I also dearly hope that none of you are still setting headlines with special fonts in images. If you are, please stop. Web fonts have advanced to the point that type in images is a relic of the past. Typekit in particular makes web fonts a snap. Google Fonts has a lot of good, if lower quality alternatives, and there are other options too, like Font Squirrel. Yes, using web fonts does add overhead to your site, sometimes significant overhead, but if we're talking about the complication of responsive images, web typography will undoubtedly be simpler. And there's exceptions to everything, right? So if you've got your name of your company, then it needs to look exactly the way that it should look, and there you're going to have to find a different solution. If you have some simple design elements on your site, like stars for a review, for example, then consider checking if a Unicode version of that design element is available, rather than using an image. This doesn't always work in some browsers, like Android 2.3, which is actually fairly common, but it's an option to consider. You can also use web fonts to create a custom set of icons that you can use. You can just take all the icons you want to use, create a custom font, and then you just have to download one font and you have all the icons that you're going to use. Again, downloading a font takes bandwidth, time, and a server hit. But if you're using enough icons, it could be better than downloading multiple images. Accessibility is sometimes a concern here. Potentially, you can set up the icon font to display icons with ligatures. It sounds weird, but you can type out Twitter, just with the letters, and then you can set up the icon font to use a ligature to replace that particular combination of letters with the Twitter icon. It can work, in theory. Icon fonts can also appear in only one color at a time, so again, your mileage may vary. Another option for icons and logos is SVG. Scalable vector graphics are finally becoming more widely supported. These work like an Illustrator EPS that can be sized up or down and still appear crisp because they are based on vectors, which are essentially math equations, rather than raster graphics, which are pixels. The code for SVG is XML, so it's easy to understand and tweak if you look at the code for it. And if you have a simple logo, then SVG is a great option. The more complex the vectors, the larger the file size, so choose wisely as to when you use this. SVGs don't work in older browsers. Old IE and Android 2.3 are culprits again. You can use tools like Grumpicon, which has a logo of a unicorn. So to generate a fallback code and a PNG so that users still see your image when you don't have SVG support. So those are our cheats: CSS3, web fonts, icon fonts, Unicode, SVG. If you can avoid using a raster image, then do so. Those are some tools you can use. Okay, I was really tired when I wrote this headline. I was up really late, so I apologize for saying Rastafarian, but anyways. Vector-based solutions are great when you can use them, but often you really need a photo in all its glorious pixels to tell a story. So what works for raster images? Before you do anything else, make sure to optimize your images. That alone can save a significant amount of bandwidth. Play around with the quality percentages on your images, compress them as much as possible while still making them look great. Just do something to make your photos as small as possible before trying anything else. For background images that are going to appear on nearly all of your site's pages, then you can embed media queries in your CSS to select the right image. In your style sheet, you could set a banner graphic with a background image property. And then with media queries within your CSS file, you could switch out the source image based on the viewport size. To make background images flex as the container size changes, you need to use the background size property using the attributes 100%, contain, or cover. Contain preserves the aspect ratio and is probably the best option, but your mileage may vary. If you're wrapping each option for your background image in a media query, browsers do a good job of respectfully downloading only the right image, which is great. The look-ahead preloader might not grab these images, however, which could increase the page load time. Background images aren't going to work in all situations. If you're working on a large site with hundreds of pages, putting all of your image logic into CSS files is completely unwieldy, so we can't use it for everything. And if your images have meaning, they would have text alternatives for accessibility purposes. You can use image replacement techniques to replace text with background images, but it gets complicated quickly. So let's take a break from photo for a second. What about video? What can we do with that? If you're using the HTML5 video element, then you can use media queries within your HTML. A video element has child source elements, and you can set a media query on each of them. The browser will display the first source element with a matching media query, so you actually want to start with the largest possible video size. And this allows you to provide large videos for larger screens and smaller videos for smaller screens. This works right now. You can start using this with videos. You can have multiple video sizes. You want to be careful about how many video sizes you put on your server since they take up a lot of space, but you can be responsible right now at providing the right quality video based on viewport size. You need to have a backup option for browsers that don't support the video element, but that's okay. A fallback object element does the trick. So you may be thinking to yourself right now, wait a minute, if we can have a special option, a special element for videos that delivers the right size of video to the right device, then why can't we have the same for images? If we had a custom element with multiple sources that used media queries to determine the right image to use, couldn't we solve a lot of problems? So it takes a bit of work to figure out which image to use in each viewport size with a complex layout. But if we do that work and we declare it in the HTML, then in theory the look-ahead preloader could pick the right image to download before it processes all of the JavaScript and CSS. The preloader could pick the right source image to download and round them up while the cell phone radio is humming, and we could just download the right image once to minimize the number of hits against the server. Why, we could even call this magical new part of HTML the picture element. No JavaScript, no fuss, no muss. And that's just what a really smart group of web folks, the Responsive Images community group, came up with. So here's the basic concept behind the picture element. Each source element gets a source attribute and a media attribute. And away we go. We can pick the right things. Almost. You may have heard about the controversy over the picture element. WYSIWYG, the Web Hypertext Application Technology Working Group, which had helped to develop HTML5, proposed an alternative syntax called sourceSet, SRC-SET, to address responsive images. And that's what it looks like. SourceSet is a new attribute for the image element. It's a complicated syntax. There's all these commas, and it's not immediately intuitive. You might think that 100W and 100W are 100 pixel wide image, but that means that that starts applying at a viewport that's 100 pixels wide. So it's kind of confusing and not intuitive initially. But allows you to define different source options based on viewport size and resolution. The trick is that you can only use min width and pixels to determine which image is used, which are important drawbacks because we've talked about using ems for our media queries. But one thing that is really useful is the fact that you can switch image sources based on the resolution of the device in a really useful and simple way by just adding 2x to the ones that are the retina images. So the long story short, there's a lot of drama, and I'm not going to cover that. The folks working on Picture modified their proposal to allow SourceSet as an attribute on source elements. This provides an easy way to define multiple resolution options for a particular viewport size, making Picture an even better option than it already was. Source set even provides some leeway to the browser on which resolution images to provide. If browsers want to provide low resolution sources in low bandwidth situations, even if you're on a Retina phone, then it can do so. Bandwidth is really hard to actually measure. There's a lot of people who talk about we should pick the right image by bandwidth, but it's really hard to figure out what your bandwidth actually is. But browsers are in the best position to make that call, because they're handling the processing of everything that's going back and forth between the server and the browser. So this gives the browser the option, and browsers could also say, hey users, you can set your image resolution preferences. I only want low res options. And they could choose that if they want. In any case, Picture is better off because of source set. One last benefit of Picture, simply shrinking down an image for a phone might not be enough. Remember, our goal is to maintain the integrity of our design. So a big image that works on a 27-inch iMac is not going to have the same impact as one on a phone in all cases. Sometimes a cropped version of that photo will make a better impact. It takes a lot of work to get this to work correctly, but since Picture allows for multiple sources, this is something we could tackle as long as we create those separate cropped images. If we just took that big picture with the White House, and you just put it on the phone, the dog would just be really tiny. So this gives us a way to still have a really good impact. So where are we at? While WYSIWYG has been reluctant to adopt the Picture element, the W3C is working on it. They've put out a first public working draft of Picture, and right now browsers are looking at how to make the Picture element work. There are some concerns about using media queries with source elements from browser makers and questions about how this would work with a look-ahead preloader, but they're looking at it. It's in the browser Chromium already, and hopefully we'll get it into some other browsers soon. Cross our fingers. So, while browsers work to implement Picture, you can still get started using it. So, polyfills are a term for some JavaScript that's used to make a new feature in newer browsers work in older browsers. And the Picture element has a polyfill called PictureFill. It was developed by Scott Gell, and he actually developed it on a raft in the Mekong River because he's a genius, and he just whipped it up on the Mekong River. And it's awesome because it allows you to use the Picture element markup pattern right now using, it used to use spans, but now it uses it used to use divs, and now it uses spans. And it uses no script surrounding the default image element. So this has some of the same drawbacks that we talked about earlier. So you might be wondering, is this, for our temporary option, Picture Fill, is this really the best option there is out there? You might be wondering. Are there options out there besides Picture? People are trying new things every day. Compressive images is an interesting technique where you create a really big picture with incredibly low quality, like 0%. And strangely, when you display it at a smaller width, it looks nice and crisp, and the file size is really small, so potentially cool. However, all that resizing seems to use extra CPU browser when it's processed and on the device that's viewing it, and that can chew up battery life. It also results in really cruddy looking images. Somebody saves the image off your site, which maybe you want that, but that's a drawback. Another new technique is called Clown Car. It uses an SVG element to pack multiple image sources into one SVG element. So a lot of things in one small thing, it's a clown car, right? And it uses CSS background images within the SVG. If you use data URI for the SVG element, so this is a technique where instead of linking to an image, you put the whole thing into the what's called a data URI, then it only takes one download. And the SVG works in a similar way as the mythical element queries. You can base your media queries on the size of the SVG rather than the entire viewport. As we discussed earlier, that means waiting for CSS and JS to process. And SVG has some support issues in older browsers. And users might not be able to download a Clown Car SVG to their computer. Again, maybe or maybe not a bad thing. Others say that all we need is a brand new image format, one that contains all the possible sizes of your image, and somehow the server will be able to figure out how much image to download. It seems quite possible that more image would be downloaded than necessary while the server and browser figure out how much is needed. And it takes a really long time to get a new image format adopted. PNG took a really long time, like 10 years long. And WebP, offers significant file savings, but it's struggling to get adopted. So we need new solutions now, not in a decade or even in 5 years. So is the picture element perfect? No. Right now with the polyhead, the polyfill, the look-ahead preloader skips picture elements, delaying download. For larger images, JavaScript is required. But the promise of picture is that once it's in browsers, it could definitely be the best possible solution. So we've been working really hard to figure out a solution for picking the right size image based on the viewport. The picture element with picture fill as a stopgap allows us to do just that. Now, how do we actually figure out which image to use based on the viewport? If you have a site with a layout that has a single column at every single screen size without any breakpoints, you're going to have challenges picking which image sizes you want to deliver and what breakpoints you're going to use, and you're going to have really freaking huge images. But in all likelihood, your layout is a series of containers. You've got different blocks that you're putting in, and you have more sidebars at larger devices and fewer for smaller devices. Maybe your design starts out with just one column at small sizes. Perhaps it moves up to 2 columns at slightly larger sizes, about what you'd see on a landscape smartphone. Around portrait tablet sizes, maybe you're up to a 4-column grid, or 6. And perhaps 8 columns for a landscape tablet. And then maybe 12 and 16 columns for laptop and desktop layouts. Making decisions on image sizes are going to be a lot easier if you're using a grid layout and your images line up with the grid. It'll also be easier if you come up with names that are shorthand for your layout breakpoints. Breakpoints aren't necessarily going to line up with devices, but you could still call your smallest breakpoints mobile vertical and mobile landscape, even if they're not the exact pixel width of a particular phone. Or you could call it small narrow and small wide, your choice. Just pick a name that's going to make sense to you. So let's say that you have a hero image type that typically takes up the entire width of your main column, no matter what layout you have. If that's the case, then you would want to start by going through each breakpoint and determining how many grid units the image will take up at each breakpoint, and then what percentage of the viewport that translates to. Keep in mind, a grid column might have a certain percentage, and if your image spans multiple columns, you want to make sure that you include the grid gutter widths too. So that's kind of one example of how you could figure out what percentage the image is going to take up at some different sizes. So now that you have that figured out for each breakpoint, then you can figure out the possible sizes for your images at each breakpoint. If you have a fluid layout, then your container size is going to flex within a given breakpoint. It's not always going to be the exact same width. So let's say that you set a mobile landscape breakpoint at 25 ems, which is about, and your next breakpoint is tablet vertical at 35 ems. So most devices use 16 pixels per em as the base font size. So that translates to the first breakpoint being 25 ems times 16 pixels, or 400 pixels, and the second breakpoint at 560 pixels. So for the mobile landscape breakpoint, we determined that your image takes up the full 100% width of the viewport. So that means now we know that at that size breakpoint, our image has a minimum width. The breakpoint starts showing up when the viewport is 400 pixels wide. If we had 100% width at that where it switched, it'd be 400 pixels. If you had it at the largest size, it would be 560 pixels. Another example, if your tablet vertical goes from 35 ems to 50 ems, That covers viewports of 560 pixels to 800 pixels on average. But here your hero image only covers 60% of the viewport size. So that means your image range goes from 336 pixels to 480 pixels. So you want to look at how big a range that is. The reason we look at it helps determine how much extra image might be downloaded at each breakpoint. Remember, downscaling gives us better quality than upscaling, which is why we use max width to make sure we don't have our image grow to be larger than our container. You have to determine how much extra image is acceptable to you. If the range is too big, you can set a breakpoint just for images in between your layout breakpoints. Maybe you set a breakpoint of 30 ems and set up different sources for 25 ems and 30 ems to reduce the amount of extra images that a user might download. If you're using max width, then for a particular breakpoint, we want to choose the largest possible image that might display within that range. For mobile landscape, we're looking at 560 pixels. So what you want to do is take one type of image, like a hero image, and make a list of all the possible image breakpoints you plan to use and what image size will work at each breakpoint to fill the space at the largest point before you switch to a new breakpoint. When you get done with that, you'll have a big list of image sizes and breakpoints. And what you'll find is that because of your layout shifts, you have some image sizes that are pretty similar across various breakpoints. Maybe you have one that is 700 pixels, another is 725 pixels, and another is 750 pixels. So you could save server space if you picked one image size that will work across 3 breakpoints. If you use 750 pixels when you otherwise would have used 700 pixels, you'd be using a 15% larger image. Maybe it's worth that trade-off to reduce the number of image variants you need to create. That's your call. And remember, you're going to want to account for retina sizes too. If you're using 2x for retina images, that means you need a list of image widths that are twice as large as the list for non-retina images. And again, you might find places where a non-retina image is pretty similar in size to a retina image for a smaller non-retina image. Maybe you can consolidate your image sizes there too. Just to keep in mind that you could have a near infinite number of breakpoints to deliver just the right size image to every potential viewport size. And if you did, you'd have a huge number of breakpoints and image files stored on the server for just one picture element. You have to draw the line somewhere, and at some point, some users are going to download more image than necessary. Try to minimize that. Maybe 30% bigger is acceptable, or 40%. Just try to strike a balance between what is best for the user and what is sensible to manage. If you have different types of images you'll use on the site, you'll want to use this process for each type. For example, if you have images that appear in sidebars on larger screens, but the full width on the device on smaller screens, then you want to calculate the number of grid columns that sort of image takes up at each breakpoint, the minimum and maximum size at each breakpoint, and then determine if there's any size consolidation that you can do. The end result is that you've done your best possible work to pick responsible image sizes to deliver to your users, no matter what device they're using, images that look great. Okay, it's been a long journey to get to this point, longer than I thought. Responsive images is complicated. You're going to see a lot of suggested solutions out there, and it's important to understand the challenges each of these solutions face. Nothing's perfect, including picture, but if you understand the why, you're going to be well prepared to tackle the how, and that's what we're going to do now in the next 1 minute and 57 seconds. We've talked a lot about the picture element, particularly because that's a solution that will be built into Drupal 8. Drupal 8 has a lot of tools built into core for responsive design, and that includes modules to work with the breakpoints and automatically generating the correct image sources for the picture element. With these tools, Drupal 8 offers one of the best ways to implement responsive design. If you have site editors that need to upload images for regularly updated content, Drupal automates making those images responsive with picture. They don't have to deal with all the code. They don't have to write the picture element stuff. Whether those images appear in a specific place for every piece of content, or your site editors need to place those images within your content area, your main content text, they can do so without ever needing to know a thing about our last, I wrote 45 minutes of our discussion. Best of all, the Picture and Breakpoint modules are available to use right now in Drupal 7. You need to do some setup work to get that started, so let's get started on that. You'll need to download the current versions of these modules and enable them, Picture, Breakpoint, and CTools. And then all that work that we did to determine which breakpoints to use for our images, as well as our layout, now we can use that and make our work worthwhile. We go into the themes.info file, and we put our breakpoints there. And then if our theme is already enabled when we've done that, we need to go into Appearance and disable a theme, and then re-enable it for these breakpoints to register with Drupal. Now you would go to Configuration, Media, Breakpoints, and all your breakpoints should show up there. Each of your types of images have a different set of breakpoints. If you don't change your image source as you move from one breakpoint to the next larger breakpoint, there's no need to declare that breakpoint in a picture group because there's no new image source. So you would go to the breakpoints page and click Add a New Group. And when you add your new breakpoint group, you can select which breakpoints to include. For each breakpoint, you can choose if you'll be providing a high resolution option with the ability to choose whether those display with screens that are 1.5x normal density or 2x. And now you have breakpoints set up for each of your image styles. Then on the breakpoints configuration page, you click on Add Responsive Styles. And you can generate a series of image styles using a quick wizard. You could create your own manually, but this is a shortcut. So you want to select an image style that you're going to clone. So image style will automatically resize your images, which is great. So you select image style base name to name all of your image styles that are going to be created. You want to use something that reflects the type of image that you're creating, like hero underscore, for example. And then to select the breakpoints that you want to use for that type of image. You click Create, and then the image styles auto-generate. You still need to configure them to set the sizes for each of those image styles. So we did all of that work and to figure out those sizes. And so we're going to go to Configuration, Media, Image Styles to get that working. All of your image styles will appear in a list, and then you need to go into each one of those and then change the settings so your images are resized appropriately. Set each one to scale, not resize, and then set the width for each to the size that you previously determined. And now you need to use the Picture module to match up your image styles with your breakpoints. Go to Configuration, Media, Picture, and you'll be able to see your various image groups. So here's what you'd see. And you're editing a group, and you go to each breakpoint and you select the appropriate image style. If you're providing high-resolution images, then you need to make sure that you select the right sources for both the 1x and 2x sources for each breakpoint. And there you go. Now you can upload one image, and Drupal will automatically generate all the source files for the picture element. You don't need to go into Photoshop and do that work yourself. That's awesome. How do we get these new picture elements to display on our site? If you have an image field on a content type, then it's really easy to display a picture element using a picture display formatter. So you go to your content type and then Manage Display, and you'll see something like this. You find your image field, and then for format, you change the drop-down from image to picture. And then when you do that, you can select the picture group for the type of image that you're displaying here. So like hero, for example, if we're doing the configuration for the hero type image. And then you want to set a fallback image style, and this is what shows up in the image element nested within the NoScript tags in case JavaScript isn't available. You're probably best off using a small mobile image style for your fallback. And for images that appear in the same place for each piece of content, you're done. If it's always on the same spot, good to go. Site editors upload a photo, ideally as large as possible, so that Drupal can do the downscaling. You don't want it to do upscaling. And then Drupal will take care of the rest. It'll downscale the photo as appropriate for each of your breakpoints. So huzzah! If this content type is going to display in views as well, if you're going to create a list of your pieces of content, that's easy to set up too. As you're setting up a view, you select your image to display under fields. And this will appear as content, colon, and then the name of your field name. And there you go. You add it as under fields. Once you do that, then you can configure the field in views. You can choose picture as the formatter for the image. And then you select the appropriate picture group as it will display in the view. This can be different from how the image will appear when you view in a node, which is neat. So you can use different styles in different places, which I think is exactly what your question was. You asked if it's full size in one place, but as a thumbnail elsewhere, this is what you would do. You would pick a different style here. So because on a node, the image part might be part of the hero picture group, displaying to the full width of the main content area. However, in a view, maybe you have a thumbnail picture group or a sidebar picture group with a separate set of sizes appropriate for how it will appear in your layout. And it can do that. And then you finally set the appropriate fallback image again, probably the mobile style. So this highlights the flexibility of picture. I'm not doing that. If you decide to change your site later, then you can alter the breakpoints that you're using and set up a different set of picture groups and image styles. And then you just change the settings for how you display the images, and they'll appear differently without having to re-upload a whole different set of images. So upload big giant images, and then even if you want to change your theme, your design later, Picture is going to be able to handle that change. And if you have content that appears in line with your main text area, Drupal can handle that. You can get that working by either using the CK editor module or by using the WYSIWYG module and downloading the CK editor library. One note, I found the best results from using the 3.x version of CK editor rather than the 4.x version. So you probably also want to install the IMCE module, and that'll allow site editors to browse their hard drive for files to upload rather than using FTP, which is really nice. And once you've installed your editor module of choice, there's just a couple things to configure, and we'll be all done here. First, you go to the configuration page for the picture module. Now there's going to be a new tab that says CK editor. For each type of image you want to allow to be inserted within a content area, you check the appropriate box. Then you go to configuration, text formats, and for each text format where you want to allow responsive images, such as filtered HTML or full HTML, you find the filters and check the box for make images responsive with the picture module. Finally, if you're using the WYSIWYG module, you need to go to configuration WYSIWYG profiles and enable the plugin responsive images with the picture module. And now your site editors can upload an image and select the picture group that they want to use. You can go back later even and change the picture group by double-clicking on the image, and that gives you a ton of flexibility. So again, even if you change it later on, you can go back and change your design later on. You can make alterations. By default, WYSIWYG is going to display the largest image size within the WYSIWYG editor, which can get really unwieldy if you upload big pictures. However, you can go into the WYSIWYG settings and set up custom CSS that has a max width percentage for the image element. And there's instructions in the picture documentation on how to do that. Okay, you're all set. You have Drupal configured and ready to go using responsive images. And that's it. We're done. We've figured it all out. Really, seriously, honestly. So I'm really sorry I took 7 minutes and 19 seconds later than I had expected to. Sorry about that. Does anybody have any questions? Okay. Yes?
You said CK editor module and then CK.
WYSIWYG can install CK editor as well. In theory, this also works with the media module. I asked Dave Reed last night. He said he hadn't seen any issues with it. I was playing around with it and got a couple of bugs, but I might have been doing something wrong. So that's another option as well. Yes? With what? Yeah. My understanding is no. My understanding is based on the base font size. That's my understanding. Asked some people, and if I'm wrong, then you can come find me right there. So, any other questions? All right, thank you very much. Well, one more question.
So do you normally set this up for any time you're using a responsive theme? Do you just want to go this route with your images, or do you just kind of let the theme?
You've got to pick your battles, right? If you're setting up a really large-scale site and you're going to have site editors, and I mean, this is probably the best solution that's out there. It takes some time to set up because you've got to do math and maybe use an Excel sheet or something to figure out for all of your breakpoints and what the sizes are going to be. So there's effort involved, and for each project, you're going to have a certain amount of time that you have to work on that project, and you may or may not have enough time. But so when you can use this, other times, if somebody doesn't have enough time, they may get a less good solution. So, which is maybe the images do download slower because all you did was upload one big image. I may or may not have done that at some point because I didn't have enough time. So, confession. So that's kind of the scoop on that. Any other questions? Thank you very much.